Hello students and welcome back to my channel. Today is the first video which we'll be discussing. I picked questions from JEE Mains 2024, 30th January, 30th January 2024 JEE Mains. So this is the first video, students. So let us start without wasting time. As you can see, the first question is match the following. Match this one with this one. Now a small suggestion, students. Just go through the options first. You can see that all the four options, A is different. Here A is matched with 2, A is matched with 1, here A is matched with 3, and A is matched with 4. So it is just enough if you can match A properly. Alright, students. And similarly, you can see even B is also matched differently. For example, in first option B is matched with 1, the second option B is matched with 2, and so on. So in B is also matched differently. Now just see, if you compare A and B, I guess surface tension is more easier than coefficient of viscosity. Is it, student? Because surface tension is simply force per unit length. Is it, students? So force will be mLT per minus 2 per unit length, means length will get cancelled. So it is simply ml per 0 t per minus 2. So 2 should be matched with 4. So just we'll go with this option number 3, because B has been appropriately matched with 4. Okay, students. Just for another confirmation, we can see kinetic energy. Whether it is any kind of energy, whether it is rotational kinetic energy or translational kinetic energy or heat energy or sound energy or light energy, it should be energy. Energy, we know it is equivalent to work, and work is force into displacement dimensionally. So force is mLT power minus 2 multiplied by L. So mL square t power minus 2. So D should be matched with work. Yes, D is matched with work. So that's all, students. We got the answer. You don't have to match all the four options, right? Is it? Unless the options force you to do so, kindly don't do that, because unnecessarily you will be wasting time. Right. Moving on to the next question. Question number 2. If 50 vernier divisions are equal to 49 main scale divisions of a travelling microscope and one smallest reading of main scale is 0.5 mm, then the vernier constant of travelling microscope. Now, student, here the vernier constant is actually the least count. You might be knowing. Even though the least count is more popular than vernier constant is rarely used. But anyway, it is equivalent to least count. And we know for these types of instruments, least count is equal to difference between one main scale division and one vernier scale division. You can always watch that vernier scale divisions are always smaller than the main scale division. So the difference between main scale division and vernier scale division. Since we have been given that main scale division is 0.5 mm, so let us convert vernier scale division in terms of main scale divisions. It has been given that 50 vernier scale divisions are equivalent to 49 main scale divisions. So therefore, one vernier scale division will be equivalent to 49 by 50 main scale divisions. Right, students? So this is 49 by 50 main scale division. So after taking LCM and all, we get 1 by 50 main scale division. So 1 by 50, what is 1 main scale division? It is half millimeter. Notice, students, that instead of writing 0.5, I written half. So that is always much more convenient. So this is 0.01 millimeter. Right, students? So we'll go with options 4. Then moving on to the next question, students. If mass is written as m equal to k, c power p, g power minus half, h power half, then the value of p will be. Constants have the usual meanings, with k being a dimensionless constant. As here we know, c is the speed of light in vacuum, capital G is the universal gravitational constant, and h is the Planck's constant. Again, it's a universal constant. Now, students, as you know, the usual method which is usually provided in books, and teachers also teach in the same manner. The usual method is to substitute the dimensions, respective dimensions of each of these quantities, the left hand side and right hand side. Then club all the dimensions of mass together, length together, and time together, and then equate the powers of mass, length, and time on all the both the faces, the sides, and then you get the equations in three unknowns. So accordingly, you have to solve. But here I will slightly go with another method, which I think is more easier and more what you call convenient also, and there are less chances that will go wrong. Okay, students, let us proceed. So here you see mass is proportional to some constant into c to the power p, and let me write this as h power half upon g power half. Let me write like this because g power minus half is there. Then in order to eliminate power half, I have to square both sides. So squaring both sides, I get m square equivalent to some new constant, let us say k dash, then c to the power 2p into h by g. So let us bring this to this side. So we have gm square is equal to k dash into c to the power 2p into h. Now as we know, there is a common thing in between these two. As you know, we have a very simple formula. Energy is equal to h into nu. So nu will be 1 by time here. So h can be written as energy into time. Is it, students? Yes. So we can write this as h as energy into time. Energy into time. Then also potential energy, gravitational potential energy is minus gm square by r. Do you remember, students? Gravitational potential energy between 2 point masses, each of mass m separated by distance r. So gm square will be numerically energy into distance. Distance r is L, r is length. So u, instead of u, I have written energy. So let us see. E gets cancelled here. Okay, students. Then we can clearly see that c to the power 2p is equivalent to L by t, that is speed only. In other words, 2p is equal to 1, equating the powers on both the sides, and then p is equal to half. We will go with the first option, students. Okay. This one method, student, I feel convenient as well as easy as compared to the usual method given in books. Okay. Right. Moving on to section D. Question number 4. The displacement and the increase in the velocity of a moving particle in the time interval of t second to t plus 1 second are 125 meters and 50 meters per second respectively. The distance travelled by the particle in t plus 2 second. Now, student, here the question is not very clear, of course. I'm sorry to say that I have picked this from internet, and we don't know the authenticity of this question because most of the questions they are given in the internet are purely memory based. So students, they are slightly under pressure during the exam time. In the exam hall, they feel pressurized, and it's quite possible that they may not be able to remember the language of the question perfectly as it was in the question. But nevertheless, we do get an idea, a pretty good idea regarding the quality of the question, the nature of the question, the level of difficulties, right? So, what I mean to say is that I think the underlying assumption is acceleration is constant. If we can have that kind of an assumption, then definitely we can solve this question. Now, you see, students, the displacement in during the time t second to t plus 1 second. That means basically it is during the t plus 1 second. During the t plus 1 second, it is the displacement is 125 meter exactly during 1 second. And we know displacement during that second is the velocity. Displacement during a particular time, particular second is basically the velocity. So the velocity is what? Initial velocity is 125 meters per second. Initial means during t plus 1 second. Also, the change in velocity is given as 50 meters per second. In other words, acceleration is 50 meters per second. In 1 second, so 50 meters per second square. So therefore, we want to know the distance travelled by the particle in the next 1 second. In the next 1 second, isn't it, student? So certainly displacement during the next 1 second will be what? So here you see the initial velocity is 125 and the new velocity is v equal to u plus at. So u plus a into t. So it is 175 meters per second, the new velocity, student. So naturally during the next second it will travel 175 meters during the next second. After t plus 1, t plus 2 comes. So during the next second it will travel a distance of 175 meters. Alright students, that's all students in this video. Thank you so much for watching my channel. Kindly subscribe to my channel and hit the like button.